Hello, my name's Julian Edgar and I'm the author of the book Modifying the Electronics of Modern Classic Cars. It's all about cars of the 1990s and 2000s. Now what I want to do today is to talk about the use of a very simple module, a module called a voltage switch. Now voltage switches are available online quite cheaply. Here's an example of a good one, but you can buy all sorts of different types and it really doesn't matter that much what type you buy. So what use is a voltage switch? Well, wherever there is a sensor on the car that's outputting a voltage, you can use its signal to control something. Sound boring? It sure isn't. Let's take a really easy example. You fitted a new radiator and the new radiator no longer has the switch that the old one used to control the radiator fans. Now you think, oh, what am I going to do? I'll have to get a hose adapter and put a new sensor in, or get one of those slightly bodgy ones that fits under the hose clamp. It's all going to be a real problem to make it all happen easily. Don't worry about doing any of that. Simply buy a voltage switch and connect its input to the output of a coolant temperature sensor. It might be the coolant temperature sensor being used by the engine management. It might be the coolant temperature sensor being used by the dashboard gauge. In each case, it outputs a voltage and we can use that voltage to trigger the switch, which in turn can trigger a relay and turn on the radiator fan. Here's another example. You want to turn something on at high throttle angles. It might be an intercooler water spray. We'll come back to it again in a moment as well. Well, you used to have to fit a micro switch to the throttle and then make a little cam that operated it. Why? Why bother? Just tap into the signal output of the throttle position sensor and then you can use it to control any additional device you want. Now you might be thinking, but won't that upset the readings of whatever is normally monitoring that sensor? No, it won't. All modern voltage switches have what is called a high input impedance. To put that in English, they take very little current, milliamps, microamps in some cases, from the circuit that they're measuring, so they don't load it down. Now the only exception to that statement is a narrow band oxygen sensor. Be very careful if you're trying to monitor the output of a narrow band oxygen sensor because they can provide almost no current, and even a high input impedance voltage switch might load it down, but that's the only one. So let's talk about this in a bit more detail. How do you set it up? How do you connect it? What do you actually do with it? Well, the first thing is to find the signal wire that you want to monitor. For a throttle position sensor, you can do that with a multimeter, back probing each of the connections until you find a connection which has a voltage that varies with throttle angle. You obviously need to have the car switched on when you're doing that. Ground one side of the meter, probe with the positive probe of the meter until you can find that varying voltage. Now, with a throttle position sensor, invariably the voltage goes up as throttle position goes up. With a coolant temperature sensor, the voltage typically goes up as coolant temperature decreases. Ooh, doesn't that make a big problem? No, it doesn't, because these voltage switches can be set to trigger with a rising voltage, or they can be set to trigger with a falling voltage. Because they run a microprocessor on them, and that microprocessor is easily programmed just with these push buttons, you can select different modes. So make sure you have the mode right, whether it's tripping on a rising or tripping on a falling, before you actually start trying to set the level at which it switches. Talking about setting the level, the switches like this set that level digitally. In fact, this particular one even has a display of the voltage that you are measuring. So if you decide you want to trip at 4.2 volts, then you can actually set it to trip at 4.2 volts. Now, the actual voltage that you set it to trip depends on how that voltage relates to the parameter that you're measuring. So, for example, if you're measuring the output of a throttle position sensor and you want to trip at any throttle position over 80%, well, move the throttle until you're near to 80%, read what the voltage is that you are monitoring, and then set the switch to trigger at that point. With the coolant temperature sensor, what I've found is it's easiest to start off with the car dead cold and then gradually warm it up until you reach the voltage at which you say want the fans to turn on. So setting the set point, you need to do it only once, unless you want to make further changes, of course, and that's the beauty. You can fine tune it subsequently. You set the set point at the voltage at which you want the switch to trip, and with a switch like this, that's set digitally on the display. Another really important aspect to think about when you're setting a voltage switch is what's called hysteresis. It's a fancy word, but all it means is what is the difference between the switch on voltage and the switch off voltage. Let's look at an example where you wouldn't want much hysteresis. Let's say you want a low fuel warning light. The sensor in the tank outputs a voltage. Well, it's actually a variable resistance, but by monitoring that circuit you can see a varying voltage. You want to turn on the light when the fuel gets to a certain low point, and then when the fuel is put in and that low point is no longer reached, you want to turn the light off. Now, in that situation you want quite low hysteresis. You want the switch on voltage and the switch off voltage to be fairly close together. If those voltages were the same, there was no hysteresis, then at the point at which the voltage switch triggers, your warning light would be flashing on and off as the fuel sloshed back and forth. So you always want to have a little bit of hysteresis to stop that chattering, to stop that on-off, in this case of a warning light. But you might set the hysteresis to only 0.1 volts. And again, with a switch like this, the hysteresis is able to be set, able to be manually input, shows on the digital display, operate the push buttons to adjust that. But in some situations, having a wide hysteresis can be really, really useful. Let's take the example of a throttle position sensor that's going to be triggering an intercooler water spray. You want the spray to come on, let's say, over 80% throttle. Now, if you had it switching off at 79% throttle, it wouldn't actually be as effective as it could be. Let's have the spray switch on at 80% throttle, but let's have the spray stay on until you drop to 50% throttle. Obviously, the spray will be on a lot longer. It'll be on at the same point, but it will stay on after you've reached that point and then dropped below it. And in the real world, you'll find that setting that hysteresis to a larger value actually works really, really well. So what else can you trigger? Well, it's really limited by your imagination. Over the years, I've turned on radiator fans. On a hybrid car that I turbocharged, a Toyota Prius, I used a voltage switch to send a signal to the air conditioner control circuit so that the car didn't turn off when you came to a halt at traffic lights. I used a voltage switch to monitor manifold pressure. So if the car had been on boost, a timer was started and then the car wouldn't switch off when you came to a halt. Obviously, you didn't want to be on full boost, come to a traffic light and the engine switch off. So that was monitoring manifold pressure. You can use it to build an overboost alarm. You can use it for anything that outputs a voltage. And that's pretty well 90% of sensors in the car. It's not going to be able to do frequency. So if you have a frequency outputting multimeter, it won't do it. If you want to use it as a rev switch, it won't do it, not without some additional circuitry anyway. But everything else that's monitored in the car typically is a voltage outputting sensor. And as I say, with the exception of the narrowband sensor, the narrowband oxygen sensor, you can monitor pretty well any of those. It's an enormously useful instrument, tool. I buy them in lots of 4 or 5. They're so cheap, it's really worth doing that. I put them in my compartments of my boxes, my component boxes, and then when I need a voltage switch I can just pull it out. I mean, even a battery charger, switch the battery charger off when you get to the right voltage. The uses are enormous, just a whole range of uses of this device. But if we go back to a car, just being able to monitor any of those sensors outputting a voltage is a very, very powerful way of triggering extra devices. So the book is called Modifying the Electronics of Modern Classic Cars. It's for cars of the 1990s and 2000s, though of course in this case with a voltage switch you can apply it to a much wider range of cars. It's out at the moment. You can order it, you can buy it, and I think it's full of really interesting approaches like the one I have just covered. Thank you.